Have you ever been sitting in an exam hall, just staring at a sentence that looks completely fine, only to find out later there was this glaring grammatical error just hiding in plain sight?
Oh, yeah. It is one of the most frustrating feelings in the world.
Right. You start second-guessing yourself, the clock is ticking, and suddenly a language you speak literally every day feels like an impossible puzzle.
Absolutely.
And, well, if you are preparing for the IBPS POMT 2026 preliminary examination, you probably know exactly what I'm talking about. But today, we are going to change that dynamic completely.
We really are. I mean, the pressure of an exam like this can definitely make your mind go blank, but for the time we have together right now, I want you to just take a deep breath.
Yeah, nice deep breath.
Exactly. We're creating a safe space here. Instead of looking at English as this, massive, intimidating list of rules designed to trip you up, we're going to break it down. We're going to build a solid conceptual framework you can lean on when that exam clock actually starts ticking.
I love that. Think of this deep dive as, like, a study session with friends who just really love untangling how language works. So what is our specific game plan for today?
Well, we are going to methodically walk through Section 1, the English language section. That means covering questions 1 through 30 entirely in order.
Okay, all 30 questions?
Yep, all of them. But we're not just going to read off an answer key. We want to show you exactly how to trace the logic from the question to the correct choice. We want to clear up those tricky gray areas so that, when you sit down for the actual test, you aren't guessing. You are operating on pure strategy.
Strategy over guesswork. I mean, that sounds perfect. So let's start with what feels like the biggest mountain to climb, which is reading comprehension. This covers questions 1 through 8.
Right, the bedrock of language proficiency.
Yeah. And the source text we are working with is a 2-part passage about India's space program. It covers Chandrayaan-3, the creation of a regulatory body called InSpace, and the struggles of the new private space sector.
It's a dense text for sure.
It is. When I see a wall of text like this, my immediate instinct is to just panic read. Like, skim it as fast as possible. How should we approach question 1?
Well, panic reading is definitely the first trap. Let's look at question 1. It asks, as per the passage, Chandrayaan-3 made India the first country to land a craft near the moons. And then the options are, South Pole, North Pole, equator, far side, or largest crater.
Okay, so a direct fact.
Exactly, direct fact retrieval. The trick here is scanning for the proper noun, which is Chandrayaan-3. When you scan part 1 of the text, you find that exact sentence. It explicitly states the landing happened near the moon's south pole.
Oh, wow. So option A is our answer.
Yep, option A. You don't need to digest the whole paragraph. Just locate that anchor word.
Okay, so find the anchor word. Let's see if that works for question 2. It asks, as per the passage, InSpace authorizes private companies to build. And the options are roads and highways, banks and markets, dams and canals, trains and metros, or rockets and satellites.
Right. So what are you scanning for?
I'd scan for InSpace in part 2. And if I look there, I see the government set it up to authorize private firms. And right there in the text, it literally says they are building rockets and satellites.
See, you let the text do the heavy lifting, so we can safely lock in option E.
That is so much less stressful. Okay, question 3 shifts slightly. It asks, as per the passage, skilled engineers and long-term funding for the young industry remain. And the options are plentiful, scarce, cheap, foreign, or idle.
So this is testing fact retrieval again, but specifically asking you to identify an adjective.
Right. So looking at the hurdles mentioned for this nascent industry, the text clearly states that funding and talent remain scarce. So option B is correct.
Spot on. And notice how distractors like plentiful or cheap are in there. They're trying to trick candidates who might just assume a space program is automatically well-funded without actually checking the text.
Yeah, testing if you were bringing in your own assumptions. Speaking of assumptions, question 4 seems like a trap for that. It asks for the main idea regarding why India's space program is admired.
This is a classic main idea question.
Right. And the options range from achieving complex missions on modest budgets to importing cheap rockets or keeping plans secret. How do you separate the main idea from just, random details?
Well, a main idea will be the umbrella that covers the rest of the paragraph. If you look at part 1, it opens by establishing the program's reputation for achieving complex missions on modest budgets.
Okay, I see that.
Yeah, and everything else in that section, like the specific missions and comparisons to other nations, it all just supports that one overarching claim. The other options, like keeping plans secret, aren't even in the text, so we methodically eliminate them and go with option A.
Got it. Moving to question 5, we have a statement verification exercise. It asks, which of the following is true as per the passage?
These can be time-consuming if you aren't careful.
For sure. We have 5 statements. A is N-Space was set up in 2022. B is the startup launched India's first private rocket in 2022. C says private firms cannot build satellites. D says funding is abundant. And E is Chandrayaan-3 was a private mission.
So, process of elimination is absolutely your best friend here. Let's walk through the timeline in part 2. In space dates to 2020, so A is out.
Right. And we already established in question 2 that private firms can build satellites. And in question 3, that funding is scarce.
Exactly, which wipes out C and D. And we obviously know Chandrayaan-3 is a national effort, eliminating E. That just leaves B.
And sure enough, part 2 explicitly records a startup launching India's first private rocket in 2022. Option B is correct.
You're doing great. Now, questions 6, 7, and 8 shift gears. They are all about vocabulary in context.
Okay, question 6 asks for the closest meaning to the word feat. Options are failure, journey, achievement, expense, or design. When I am stuck in a vocabulary word, I try to look at the sort of the vibe of the sentence.
For a vibe, I love that.
Yeah, like the text says, the landing drew worldwide praise. So praise is obviously positive.
That is the perfect strategy. We call that checking the polarity of the context. Because praise is highly positive, the word feat must represent something positive.
Right, so failure and expense are negative. Journey and design are just neutral. Achievement is the only inherently positive synonym there. So option C is the answer.
Exactly. Let's apply that same polarity check to question 7. Closest meaning to nascent. Options are emerging, declining, ancient, profitable, complete.
Okay, the context clues talk about a young industry facing early hurdles, and it was recently opened up. So words like declining, ancient, or complete clash completely with the idea of youth.
Right, they are totally antonyms.
So emerging, option A, fits that context perfectly.
You've got it locked in. But now watch out for question 8 because the test makers actually flipped the instruction here.
Oh, let's see. They want the word most opposite in meaning to modest. Options are humble, small, simple, quiet, lavish.
This is a huge trap. In the stress of the exam, you might just look for a synonym out of habit.
Oh, I would totally do that. I'd just pick humble or small and move on.
Right. But we need the definitive opposite. If the budget is modest, we define that as limited. So the complete opposite of limited spending would be extravagant or excessive.
Which leads us directly to option E, lavish.
Exactly. And that wraps up reading comprehension. Notice how we didn't have to rely on any outside knowledge. The passage provided every single answer.
It's just like being a detective. The text is the crime scene, and it provides every single alibi, every clue. You never really have to guess, you just have to observe.
That is such a great analogy, and that observational skill is going to carry us right into segment 2, which is the cloze test. This spans questions 9 through 13.
Okay, so moving from macro comprehension to micro context.
Precisely. A cloze test evaluates semantic harmony and grammatical collocations. Basically, how well words fit together. The text for this section is about rainwater harvesting.
All right, let's dive in. The paragraph starts, cities that once received ample rain now blank, which is question 9, water shortages every summer. Options for blank 9 are enjoy, deny, face, invite, spread. I guess we are looking for how a city naturally interacts with the shortage?
Right, we need a verb collocation. Logically, a population does not enjoy or invite a lack of water.
No, definitely not.
And deny just doesn't fit the reality established by the sentence. You confront a problem. Therefore, the natural pairing in English is face a shortage. Option C.
Okay, makes sense. The next sentence says, experts blank, that's number 10, that rainwater harvesting can recharge groundwater. Options are maintain, refuse, doubt, forbid, conceal.
So think about verbs of assertion here.
Right. If experts are proposing a solution, they wouldn't hide it or doubt it. The sentence is outlining a positive claim. So maintain, option A, meaning to strongly state or assert, is the only logical fit.
Perfect. Continuing that sentence, can recharge groundwater if it is blank. 11, widely. Options are rejected, buried, painted, sold, adopted.
Well, a technique must be implemented to yield results, right? They can't reject or bury it. The formal word for taking up a practice is adopted. Option E.
Yes. Then the text shifts from the experts to the government. Several states have made such systems blank, 12 for new buildings. Options are optional, mandatory, invisible, decorative, temporary.
So we have to think about the legal or state context here. If there is a severe shortage, state intervention transforms a choice into a compulsion. They wouldn't make it optional. It has to be option B, mandatory.
Exactly. And finally, blank 13. And residents who install them soon notice the blank 13 in their wells. Options are decline, silence, shortage, confusion, improvement.
Okay, I want to push back on this one a bit. Sometimes these options look interchangeably correct. Like in an exam, my brain might see shortage and think, oh, the whole passage is about shortages. I should pick that. How do I avoid second guessing?
That is a very common pitfall. The absolute best way to avoid it is by relying strictly on the structural words immediately surrounding the blank.
So don't just go off the general theme.
Right. Don't let the overall theme override the local sentence structure. Look earlier in the very same sentence. It says the systems recharge groundwater. That establishes a positive semantic consistency.
Oh, I see. A recharged well is a benefit.
Exactly. Decline and shortage are negative outcomes. Improvement, which is option E, is the only choice that maintains the positive harmony of that specific sentence.
That is incredibly helpful. Focus on the immediate architecture, which actually bridges us perfectly into segment 3. Parajumbles. This is questions 14 through 17, where we transition from filling blanks to structuring entire narratives.
Yes, parajumbles. We have 5 sentences about reading to children, and we have to build a logical paragraph.
When I look at a jumbled mess like this, I don't even know where to start.
You always start by finding the introductory hook, the foundation. Let's look at the options. A is, such children pick up new words faster than their peers. B, a small home library can turn this habit into a lifelong gift. C is, reading aloud to children builds their love for books early. D is, schools therefore ask parents to read with children daily. And E is, they also learn to sit with a story and concentrate.
Okay, so sentence A starts with such children, which implies it's referencing a previous sentence.
Right, it's not independent.
D has, therefore, so it's a result. E has also, which is an addition. So sentence C is really the only one that introduces the topic without relying on previous context.
Spot on. C is our foundation. So for question 14, which asks for the first sentence, we lock in option C. Then what?
Then, I guess we look for the benefits of that premise. Sentence A gives us the first benefit, picking up words faster, and sentence E gives us the second benefit, signaled by also that they learn to concentrate.
Exactly. The logical progression is C, then A, then E.
And because of those benefits, there is a consequent action. That brings in the therefore in sentence D. Schools therefore ask parents to read with children. So D follows E.
Which perfectly answers question 15, identifying the fourth sentence. That would be option D.
Right, and that leaves sentence B as the ultimate conclusion, wrapping up the idea of a lifelong gift. So the full sequence is CAEDB.
Exactly. You nailed the rigid logic of it. Topic intro, benefits, action, conclusion. So for question 16, asking for the ASTI sentence, we choose option B. And for question 17, asking what comes immediately sequentially after sentence E, we know from our linkage that it's option D.
It's so satisfying when it just clicks into place like that. All right, let's shift gears into segment 4, error spotting, questions 18 through 22. Now, I know this section causes candidates a lot of anxiety. It's all about the mechanics of the English language.
It really does cause anxiety, and I have a lot of compassion for anyone feeling that way. But I like to frame grammatical rules as reliable mathematical formulas. They don't change based on how the sentence just sounds in your head.
Right, they rely on consistent logic. Let's test that out with question 18. Each of the students, A, have submitted, B, their assignment, C, on time, D.
What does your instinct tell you?
My brain instantly sees students have and thinks, well, students is plural, have is plural, so it sounds fine to me.
And that is the exact trap. The test makers use the plural prepositional phrase of the students to distract you from the actual subject, which is the word each.
Oh, each is the subject.
Yes. Each is a distributive pronoun. It takes a group and isolates the individuals within it one by one. Therefore, each functions as a singular entity no matter what plural words follow it.
Wow. Okay, so the formula is each plus a singular verb.
Exactly. Part B is incorrect because have should mathematically be has. Option B is the answer.
That is so sneaky. Okay, question 19. The Ganga is A, longer than B, any river, C, in India. D, what's the formula here?
This tests logical exclusion in comparative degrees. Think about the logic. If you say the Ganga is longer than any river in India, you are creating a logical fallacy.
Wait, because the Ganga is a river in India. So by saying any river, I am accidentally implying the Ganga is longer than itself.
Precisely. You are comparing the subject to a group that currently includes itself.
That makes no sense.
Right. To fix the formula, you have to explicitly exclude the subject from the rest of the group. You do that by adding the word other. It must read longer than any other river in India. So the structural crack is in part C, option C.
I see it now. Let's look at question 20. He returned back A, to his village, B, after completing C, his training, D, I hear people say returned back literally all the time.
They do. It's very common in casual speech, but in formal grammar, it's a redundancy error. Let's deconstruct the word return. The prefix inherently means going back to a previous state or place.
Oh, so the meaning of back is already baked right into the word.
Yes. Adding back next to it is entirely redundant. The sentence should simply be, he returned to his village. The error is in part A, option A.
Got it. Okay, question 21. My brother is A, an MA-B in economics, C, from Delhi University, D. Okay, I remember this rule from school. We use A before consonants and an before vowels. M is a consonant, so shouldn't it be A, M-A?
That is exactly what they want you to think. But let me clarify the phonetic rule here. The rule isn't about how the letter is spelled on the page. It is entirely about how the letter sounds.
Wait, really?
Yes. When you pronounce the letter M by itself, you say M. It produces the A vowel sound.
Oh, wow. M? Yeah, it does.
Because the pronunciation initiates with a vowel sound, and MA is technically correct. There is no error here. So the correct resolution is option E, no error.
Sound not spelling. I will definitely remember that one. Question 22. The officer ordered A, the peon, B, to bring the files, C, immediate, D.
This tests adverbs modifying verbs. We have to break down the distinction between describing a noun versus describing an action.
Right. Adjectives describe nouns, like an immediate response. But adverbs describe actions, like how something is done.
Exactly. Here, the word needs to modify the action, the verb bring. How should the file be brought? Immediately. It requires the adverbial lie ending, so the error lies in part D, option D.
All right, so we've spotted the cracks. Now, in segment 5, which is phrase replacement, questions 23 to 25, we have to actively repair them. Let's start with question 23. Replace the phrase in quotes. He is used to drive on the left side of the road. Options are to drove, to driven, to driving, to be drive, or no improvement.
This is a highly tested concept. It revolves around neutralizing the theoretical ambiguity around the word to. Most of the time, to is an infinitive marker sitting next to a base verb like, I want to sleep.
Right.
But in the specific phrase used to, when it implies being accustomed to something, the word to actually functions as a preposition.
And prepositions have different rules. You can't just slap a base verb after them.
Precisely. Prepositions must be followed by a noun or a gerund, which is the ing form of a verb functioning as a noun.
So you wouldn't say, I am accustomed to drive. You say, I am accustomed to driving.
Yeah, exactly. Therefore, to driving is the structurally accurate fix. Option C is the answer.
That makes total sense when you map it out. Okay, question 24 is another specific phrase. It is high time we start the meeting. Options are started, will start, starting, would starting, or no improvement.
This is testing the subjunctive mood. The phrase, it is high time, is a rigid framework in English. It expresses that an action is overdue, it should have already happened.
But we want the meeting to start right now in the present, right?
We do, but to convey that sense of an overdue reality, the grammatical rule dictates the phrase must be followed by the simple past tense. The past tense started signals the hypothetical overdue nature of the action. Option A, started, validates this rule.
So interesting. Okay, question 25. He did not wrote the letter that was promised. Options are does not wrote, did not written, do not writes, did not write, or no improvement.
This evaluates auxiliary verbs and base forms. Did has is the auxiliary or helping verb here.
You know, I always try to visualize this. I like to think of the auxiliary verb did like a designated driver.
A designated driver. I like that.
Yeah, like when did is in the sentence, it takes on all the heavy lifting. It carries the weight of the tense, so the main verb doesn't have to do any work. The main verb just gets to sit back and relax in its base form.
That is an excellent, memorable analogy, and it is grammatically spot on. Because did already carries the past tense weight, putting the main verb wrote in the past tense as well is a double past error. The designated driver has it covered.
Right, so the main verb must revert to its base form, right. Did not write. Option D is the correct repair.
Absolutely.
Let's carry that momentum into segment 6. Fillers, questions 26 through 28. This is testing contextual vocabulary where words must satisfy both meaning and societal idiom.
Right, the words have to fit naturally into standard phrasing.
Okay, question 26. The minister blanks the new bridge and blank it to the public. Options are demolished and dedicated, inaugurated and dedicated, inaugurated and denied, painted and sold, or delayed and gifted.
We are looking for standard institutional collocations here. Think about the specific vocabulary used for public works ceremonies.
Well, a minister doesn't paint or demolish a new bridge. They formally open it. The customary verb is inaugurate.
Right, and then they formally offer it for public use, which we call dedicating it. Option B, inaugurated and dedicated, is the only pair that respects the logic of that ceremony.
Okay, question 27 involves the economics. Farmers were blank to sell below cost, so the government blank a support price. Options are eager and withdrew, reluctant and announced, reluctant and opposed, happy and announced, unable and hid.
Let's map out the logical trajectory. Cause and effect semantics. If farmers are asked to sell goods for less than it costs to grow them, human nature says they would resist.
Right, they would be reluctant, which instantly eliminates options A, D, and E.
Exactly. And if there is economic resistance, the government has to offer a policy remedy. Opposing a support price wouldn't fix their reluctance. They would step in and announce a support price.
That makes option B, reluctant and announced, the perfect logical map.
Yes. Now, question 28. The audit blanked several errors that had blank unnoticed for years. Options are revealed and gone, hidden, gone, revealed and grown, caused and stayed, praised and slipped.
Well, the fundamental purpose of an audit is to investigate and uncover things. So an audit wouldn't hide or praise errors.
Yeah.
It would reveal them.
Exactly. And for the second blank, we explore an established English idiom. When something escapes attention for a long time, the phrasing is that it has gone unnoticed.
So option A, revealed and gone, provides both the logical action and the idiomatic phrasing.
Perfect.
Which brings us to our final sprint, segment 7, vocabulary and idioms. Just questions 29 and 30 to go. Let's finish strong on pure vocabulary. Question 29 asks for a one-word substitute. A person who can speak 2 languages. Options are linguist, translator, bilateral, bilingual, verbose.
This is a test of one-word substitution based on root words. Let's deconstruct the prefix bi and the root lingua. Bi means two, and lingua refers to tongue or language.
So combining them gives us bilingual, option D.
Yes. And just to neutralize any ambiguities, let's look at the distractors. A linguist studies the science of language. A translator converts text. Bilateral refers to something having 2 sides, usually in negotiations. So bilingual is the definitive match.
And our final question, question 30. Choose the correct meaning of the idiom to burn the midnight oil. Options are to waste money on luxuries, to lose one's temper quickly, to celebrate a festival, to destroy old records, or to work or study late into the night.
Idioms can be tough if you translate them literally. The best strategy is to explain their historical origin. Before electricity, how did people see after dark?
They relied on oil lamps.
Right. So if you were burning that oil at midnight, you weren't sleeping. You were awake, laboring, or studying long past regular hours to cement it in your memory. The idiom means to work or study late into the night. Option E is the correct resolution.
Which is incredibly fitting because by methodically getting through all 30 of these questions with us today, you are successfully burning the midnight oil for your IBPS CRP POMT exam prep. I just want to commend you for your dedication.
I agree completely. Please remember, every single error we spotted today and every rule we unpacked is a brick in your foundation of language mastery. You aren't just memorizing 30 answers, you are learning how to decode the mechanics of the exam.
Absolutely. So as we wrap up, we want to leave you with a final provocative thought to mull over. It is really easy to view grammar as just this rigid set of rules designed to penalize you on a test.
But it's really not.
No, it's the fundamental architecture of clear, persuasive human thought. We challenge you to start noticing these structures out in the wild. Before your exam, when you read an article or just have a conversation, look for those collocations. Notice how prepositions behave. Spot the idioms.
Once you start seeing the architecture around you every day, the exam hall stops being a scary place. It just becomes a space to demonstrate your understanding.
Beautifully said. We wish you incredible success on your upcoming deep dives and, of course, on your exam. Keep observing, keep questioning, and keep building that foundation. Take care.
Imagine taking a really high-stakes exam, doing all the math perfectly, and then realizing the correct answer is like confidently saying, I don't know.
Right, which goes against every instinct you have in a test.
Completely. But today, we are conquering Section 2 of the IBPS POMT 2026 Preliminary Examination Model, Paper 04. And specifically, we're taking on the quantitative aptitude section. We're going sequentially, working from question 31 all the way through 65.
Yep, the whole section.
So if you're gearing up for this test, or Honestly, if you just want to sharpen your logical reasoning, you are in exactly the right place for this deep dive.
Absolutely. And, before we look at a single number,
Right.
let's just take a collective breath.
Good idea.
Because looking at a block of 35 math questions, that can make anyone's heart rate spike. It's totally normal to feel a bit overwhelmed by it all.
Oh, for sure.
But we are right here with you. We are going to guide you through this step by step. We're explaining not just what the answers are, but exactly how to find them.
We're navigating this together because, this section isn't just some random assortment of calculations designed to trip you up. There's actually a very deliberate flow to it.
There really is. It's a beautiful progression, honestly. Yeah. The test designers start you off by reading visual data, right? Then they transition you into understanding abstract algebraic relationships.
Mm-hmm.
Then they test your pattern recognition. And finally, they make you take all those tools and apply them to solve tangible, real-world scenarios.
Mm-hmm.
It's like a complete narrative arc of logic.
Okay, let's unpack this and dive into section 1. Visualizing the story. We're starting with data interpretation and analysis, which covers questions 31 through 40.
Right. And before we get into any of the heavy lifting, we start with visual information. Data interpretation is really just about letting the numbers tell you a story before you do any complex math.
It makes me think of looking at the dashboard of a car. You don't need to know how to build a combustion engine to look at the speedometer and understand how fast you're going.
Exactly.
You just need to know how to read the dial.
That is a perfect analogy. You're just reading the dials. So let's look at the first set of dials. We've got a bar graph detailing the production of two companies, Company A and Company B, from the year 2021 to 2025.
Okay, let's track their growth. So question 31 asks, in which year was the total production of the two companies together the highest?
And the strategy here is simple addition before anything else. Just look at the combined totals year by year. If you stack the bars for A and B, the sequence is 55,000, then 75, 80, 100, and finally 95,000 in 2025.
Oh, wow. So you don't even need to write much down to see the peak was clearly in 2024.
Right, at exactly 100,000 units.
Super straightforward. Once you have the raw numbers, the next logical step in analyzing a business is tracking its growth rate. So question 32 asks for the percentage increase in the production of Company B from 2021 to 2023.
Right, and to find a percentage increase, you need that classic formula. The difference in production divided by the original starting number multiplied by 100. So Company B produced 25,000 units in 2021, and they jumped to 45,000 in 2023.
Meaning an absolute difference of 20,000.
Yep. So we take that 20 divided by the original 25 and multiply by 100.
And 20 divided by 25 is essentially 4/5, which translates to a massive 80% jump.
Yeah, that is a solid couple of years for Company B.
Definitely. Moving along, question 33 asks us to establish a ratio. We need the ratio of Company A's production in 2022 to Company B's production in 2025.
Okay, so Company A in 2022 was at 40,000. Company B in 2025 was at 55,000. So your baseline ratio was 40 to 55. And to simplify a ratio, you just find a common denominator.
Well, both end in 0 or 5, so we can just divide both sides by 5.
Exactly. 40 divided by 5 is 8, and 55 divided by 5 is 11.
Giving us a clean 8 to 11.
Spot on.
Question 34 shifts to averages. Specifically, the average annual production of Company B over the entire 5-year span.
Right. And for an average, you just sum up the total and divide by the number of data points. Company B's production over the 5 years was 25 plus 35 plus 45 plus 50 plus 55.
Which totals 210,000.
Yep. Divide that total by the 5 years and you get an average of 42,000 units annually.
Okay, wrapping up our bar graph dashboard is question 35. By how many units does the 5-year total of Company B exceed that of Company A?
Well, we just calculated B's 5-year total was 210,000. If we run that same simple addition for Company A, we get 195,000.
And the difference between 200 and 195 is 15, meaning Company B produced 15,000 more units than A over that time frame.
Exactly. So the real takeaway there is to always keep track of your previous calculations on your scratch paper.
Right, because we used B's total from question 34 to basically instantly solve question 35.
Exactly. It saves so much time.
Okay, now for the second half of this data section, questions 36 through 40. We transition from a visual graph to a text-based caselet. It's basically a word problem about this guy Ramesh and his monthly budget. We're told his monthly income is 48,000 rupees, he spends 25% on rent, 35% on food, 15% on travel, and he saves whatever is left over.
Right, so instead of a bar graph, this is essentially a classic budgeting pie chart, but it's just described in text.
Makes sense. Question 36 asks, what is Ramesh's monthly savings?
So first, we have to figure out what chunk of the pie he is actually spending. You add the percentages, 25% plus 35 plus 15.
Which equals 75%.
Right. If 75% of his income is gone, he saves the remaining 25%. And 25%, which is just 1/4, right, of his 48,000 rupee income, is 12,000 rupees.
Nice and clean. Question 37 asks how much he spends on rent and travel together.
Again, combine the percentages first before you do any math with the big numbers. Rent is 25%, travel is 15%. Together, that's 40%.
And 40% of 48,000 gives us 19,200 rupees.
Exactly.
Now, question 38 looks for a ratio again. The ratio of his expenditure on food to his expenditure on rent. And I mean, I'm guessing we don't actually need to calculate the raw rupee amounts for both of these just to compare them, right?
You're spot on. Since both percentages are drawn from the exact same total income of 48,000, calculating the raw numbers is just a total waste of precious exam time. You can compare the percentages directly.
Okay, so food is 35, rent is 25.
Yep, and 35 to 25 simplifies by dividing both by 5, bringing us down to a ratio of 7 to 5.
That is a vital time-saving trick. Question 39 shifts the timeline. It asks how much he spends on travel in a full year.
Ooh, this is a classic trap. You have to pay close attention to the wording.
Because everything so far has been monthly.
Exactly. His monthly travel is 15% of 48,000, which is 7,200 rupees. But to get the annual figure, you must multiply that 7,200 by 12 months.
Which yields 86,400 rupees a year.
Yep. If you just put the monthly number, you'd get it wrong.
Sneaky. Okay, question 40 is a fun one. It's a what-if scenario. What if Ramesh cuts his food expenses by 10% while everything else stays the same? What will his new monthly savings be?
Let's just break it down logically. His original food expense was 35% of 48,000, which is 16,800 rupees. If he trims that specific category by 10%, he's releasing 10% of 16,800 back into his pocket.
Which is 1,680 rupees.
Right. We just take that released cash and add it to his original savings of 12,000. So his new savings sits at 13,680 rupees.
And just like that, 10 questions down. Which brings us to section 2, finding the balance. Questions 41 through 45 focus on equations and inequalities. Now, I have to push back a little here. We just went from calculating a highly relatable monthly budget to, well, comparing X and Y in abstract quadratic equations. Why do we even need to do this? What is the real-world value of this?
No, it's a very fair question. It feels like we just left reality behind, right? But quadratics are actually all about evaluating potential outcomes. In real life, especially if you're in business or economic scenarios, rarely have one single definitive answer.
True.
They have ranges and possibilities depending on market factors. Solving these equations is really just training your brain to compare two different sets of possibilities and determine if one scenario is definitively better, worse, or just too ambiguous to call.
Okay, training the brain to handle ambiguity. Actually like that. Let's see how that works with question 41. We have equation I, which is x squared plus 9x plus 20 equals 0. And equation 2, y squared minus 2y minus 3 equals 0. Walk us through the mechanism here.
Well, for standard quadratic, we are looking for two numbers that multiply to the final number, but add up to the middle number. So for equation I, we need numbers that multiply to 20 and add to 9.
Which are 4 and 5.
Right. But because the equation is set to 0, we flip the signs for the actual roots, making them -4 and -5.
Got it.
Then for equation 2, multiplying to -3 and adding to -2 gives us roots of 3 and -1. When you compare them, both -4 and -5 are smaller than both 3 and -1. So we definitively say x is less than y.
Okay, question 42. Equation I is x squared minus 12x plus 36 equals 0. Equation 2 is y squared minus 10y plus 24 equals 0.
So for equation I, multiplying to 36 and adding to -12 means our numbers are -6 and -6. Flipping the signs, x has only one root, which is 6.
Okay, and for equation 2?
Multiplying to 24 and adding to -10 gives -4 and -6. Flipped, y is 4 or 6, so let's compare those. If x is 6, it is greater than 4, but it's equal to 6. Therefore, the relationship is x is greater than or equal to y.
Makes sense. Question 43. Equation 1, x squared minus 5x plus 4 equals 0. Equation 2, y squared minus 6y plus 8 equals 0.
Now, this right here is a crucial lesson. Multiplying to 4 and adding to -5 means x roots are 1 or 4. Multiplying to 8 and adding to -6 means y roots are 2 or 4.
Okay.
Let's test the scenarios. If x is 1, it's less than y. But if x is 4, it's equal to one of the y values, and it's actually greater than the other y value of 2.
Oh, I see. Because x can be smaller, equal, or greater depending on which roots you happen to pair up. No definitive relation can be established.
Precisely. It's okay in math and in life, honestly, to admit when the data doesn't give you a clear-cut relationship. Sometimes the most accurate answer is we don't know. Forcing a relationship where none exists is a critical error.
I love that. Let's look at question 44. Equation I, x squared minus 17x plus 72 equals 0. Equation 2, y squared minus 11y plus 28 equals 0.
Okay, multiplying to 72 and adding to negative 17 gives us x roots of 8 and 9. For y, multiplying to 28 and adding to negative 11 gives us 4 and 7. Since 8 and 9 are both strictly larger than 4 and 7, every possible value of x exceeds every possible value of y.
Thus, x is greater than y.
Exactly.
And wrapping up this section, question 45, equation 1, x squared minus 6x plus 9 equals 0. Equation 2, y squared minus 7y plus 12 equals 0.
Equation I resolves to just one root dash equals 3. Equation 2 gives y roots of 3 or 4. Since 3 is equal to 3, but less than 4, we easily conclude that x is less than or equal to y.
Perfect. That brings us to section 3, the rhythm of math. Questions 46 to 55 cover number series and simplification. We're moving from comparing abstract ranges to straight-up pattern recognition.
Which is always fun.
Yeah, I always compare number series to musical beats. You know, once you recognize the rhythm of the sequence, the wrong note stands out completely.
That's a great way to look at it.
Let's try to find the wrong notes. Question 46. The series is 12, 14, 25, 38, 63, 101. Okay, so 12 to 14 is a gap of 2. 14 to 25 is a gap of 11. My brain instantly wants to look at the gaps, but there's no real pattern there.
You're right to check the gaps first, definitely. But when that fails, look at the totals. The underlying rhythm here is actually a Fibonacci-style sequence where each term is the sum of the previous two. Look at the end of the series. 25 plus 38 is 63. 38 plus 63 is 101.
Oh, but at the start, 12 plus 14 does not equal 25.
Exactly. The wrong note is 14. It should be 13 because 12 plus 13 gives you that 25.
So clever. Question 47, 2, 5, 10, 17, 27, 37. Okay, if gaps aren't working, what about squares? 1 squared is 1, plus 1 is 2, 2 squared is 4, plus 1 is 5.
Exactly. You found the rhythm. The pattern is the number squared plus 1. 3 squared plus 1 is 10. 4 squared plus 1 is 17. Following that rhythm, 5 squared plus 1 should be 26. So the imposter here is 27.
Got it. Question 48, 5 times 10, 30, 120, 610, 3600. Wow, the numbers are getting huge very fast, so this has to be multiplication, right? 5 times 2 is 10, 10 times 3 is 30, 30 times 4 is 120.
You've got it. It's an increasing multiplier. So the next step is 120 times 5, which should be exactly 600. So that 610 breaks the rhythm entirely.
Question 49, 2, 9, 28, 66, 126, 217. Okay, this feels like the squares from question 47, but steeper. Cubes, maybe?
Spot on. It's a number cubed plus 1. 1 cubed plus 1 is 2. 2 cubed plus 1 is 9. 3 cubed is 27, plus 1 is 28.
And 4 cubed is 64, plus 1 should be 65. So 66 is the incorrect number.
Exactly.
And question 50, the last of the wrong numbers, 15, 21, 27, 33, 39, 46.
Oh, this is the simplest rhythm of all, just to give your brain a break. It's just a steady additive step of plus 6.
Okay, so 39 plus 6 is 45, therefore 46 is the wrong number.
Yep.
Now for questions 51 through 55, we hit simplification and approximation. These can look really intimidating on the page with all the percentages, fractions, and square roots.
They look scary by design.
Yeah.
But simplification is really just testing your confidence to break big, ugly problems into small, bite-sized pieces you already know how to digest.
Let's see that in action. Question 51, 42% of 550 plus 16% of 1625.
Don't panic, just break it down. 42% of 550 is essentially 5.5 times 42, which is 231, and 16% of 625 is a nice clean 100. Add those pieces together. 231 plus 100 equals 331.
Oh, that's not bad at all. Question 52, 15% of 840 plus the square root of 1296. Now, 15% of 840 I can manage like, 10% is 84, half of that is 42, so that's 126. But how am I supposed to calculate the square root of 1296 in my head?
But looking at the boundaries,
Yeah.
30 squared is 900 and 40 squared is 1600, so it has to be in the 30s. The number ends in a 6, which means the root must end in a 4 or a 6.
Oh, right.
And 36 squared is exactly 1296. So your 126 plus 36 gives you 162.
Ah, Yeah. Okay, question 53 involves fractions. 712th of 960 minus 58ths of 640.
Just take it one fraction at a time, divide by the bottom, multiply by the top. 960 divided by 12 is 80, and 80 times 7 is 560.
And for the second part, 640 divided by 8 is 80, and 80 times 5 is 400.
Right. And 560 minus 400 leaves us with a clean 160.
Nice. Question 54 is an approximation question. 24.99% of 799.99 plus 33.33% of 599.99.
Now, the profound insight here is that the test makers don't actually want you to do the grueling decimal math, right?
Right.
They are testing your confidence to basically break the rules and round the numbers.
Okay, so 24.99% is just 25% or 1/4, and 799.99 is basically 800. A quarter of 800 is 200.
Exactly. On the other side, 33.33% is 1/3, and 599.99 is 600. A third of 600 is also 200. 200 plus 200 easily gets you 400.
So much easier than it looks. And finally, question 55. 19 squared minus 14 squared plus 3 cubed.
Rather than calculating those large squares, just use the difference of squares shortcut mechanism. A squared minus b squared is just a plus b times a minus b.
Okay, so 19 plus 14 is 33. 19 minus 14 is 5. 33 times 5 is 165.
Yep. Add 3 cubed, which is 27, and you arrive at 192.
Brilliant. And just like that, we enter section 4, the real world, questions 56 to 65. If you are listening to this on a commute or a walk, this is the part where you really have to visualize the scenario with us. We are moving off the spreadsheet and into real physical spaces.
Exactly. This is the application phase. We're taking the tools out of the toolbox and building something with them.
Let's build. Question 56 is a time and distance problem. Two trains of lengths, 120 meters and 180 meters, are running toward each other at 42 kilometers per hour and 66 kilometers per hour. And how much time will they cross each other?
Imagine two long strings being pulled past each other.
Yeah.
You have to add their lengths together to know the total amount of string that has to pass. 120 plus 180 means there are 300 meters of train to clear.
Right, and because they are moving toward each other, we also combine their speeds for the relative speed. 42 plus 66 is 108 kilometers per hour.
Wait, but our distance is in meters and our speed is in kilometers.
Ah, we have to convert that.
Yes. To convert kilometers per hour to meters per second, you multiply by 5 over 18. 108 times 5 over 18 equals 30 meters per second.
Okay, so a distance of 300 meters divided by a speed of 30 meters per second means they clear each other in exactly 10 seconds.
Perfect. Visualizing it makes all the difference.
Question 57 tackles compound interest. Find the compound interest on 10,000 rupees at 20% per annum for 1 year, but it's compounded half yearly.
Right. Because it's compounded half yearly, that 20% annual rate is cut in half to 10%, but it's applied twice.
Got it. So 10,000 plus 10% gives 11,000 for the first half of the year.
Then 11,000 plus 10% gives 12,100 for the end of the year. Subtract the original 10,000 principal, and your interest yielded is 2,100 rupees.
Speaking of combined efforts, let's look at question 58 on time and work. Person A and person B together can finish a job in 8 days. Person A alone can finish it in 12 days. How many days would it take person B alone?
The trick here is to look at their daily output. Together they do 1/8 of the work per day. A alone does 1/12 of the work per day. To find B's share, subtract A's work from the total. So 1/8 minus 1/12.
Okay, to subtract those, I need a common denominator. For 8 and 12, that would be 24. So 1/8 becomes 3/24 and 1/12 becomes 2/24. 3 minus 2 leaves 1/24.
Perfect. If B does 1/24 of the work per day, it takes B exactly 24 days to finish the job alone.
Question 59 is a classic ages problem. A father is 3 times as old as his son. After 12 years, he will be twice as old. Find the father's present age.
You just set up the variables. Let the son's current age be x, the father's 3x. In 12 years, the father is 3x plus 12, and the son is x plus 12.
Okay.
So the equation is 3x plus 12 equals twice the son's future age, so 2 times the quantity x plus 12.
So 3x plus 12 equals 2x plus 24. Subtract 2x from 3x to get just x. Subtract 12 from 24 to get 12. So x, the son, is 12. And since the father is currently 3 times the son's age, 3 times 12 means the father is currently 36.
Spot on.
Question 60 tests probability. 1 card is drawn at random from a standard 52-card deck. What is the probability that it is a face card?
Well, a standard deck has jacks, queens, and kings in 4 suits. That's 3 times 4, which is 12 face cards total.
So the chance of pulling one is 12 out of 52.
Yep. To simplify, both divide by 4, reducing the probability down to 3 out of 13.
Question 61 shifts back to business with profit and loss. The cost price of 15 articles equals the selling price of 12 articles. Find the profit percent.
This phrasing basically means you recover all your initial costs by selling just 12 of the items.
Meaning the remaining 3 items you sell are pure profit.
Exactly. 3 profit items over a cost base of 12 items is 3 over 12, which simplifies to 1/4, or a 25% profit.
Question 62 takes us out on the water. A boat's speed in still water is 10 kilometers per hour, and the stream flows against it at 2 kilometers per hour. How long will the boat take to travel 32 kilometers upstream?
When going upstream, the stream physically fights the boat. So the effective speed is the boat's speed minus the stream speed. 10 minus 2 gives an effective speed of 8 kilometers per hour.
And to travel 32 kilometers at a speed of 8 kilometers per hour will take exactly 4 hours.
Yep.
Question 63 involves percentages and exam scores. A student scoring 33% fails by 25 marks, while another scoring 45% gets 11 marks more than the pass mark. What are the maximum marks of the exam?
Don't worry about the passing mark itself here. Just look at the gap between the two students. One is 25 marks below passing, the other is 11 marks above.
So the total gap in marks between them is 25 plus 11, which is 36 marks.
Right. Now look at the gap in their percentages. 45% minus 33% is 12%. So a 12% gap equals 36 marks.
So if 12% is 36, then 1% is 3, meaning 100%, the maximum marks would be 300.
Exactly. Find the gap, find the total.
Question 64 tests mensuration. The circumference of a circle is 88 centimeters. Find its area, taking pi as 22 over 7.
We have to work backward. Circumference is 2 times pi times the radius. So 88 equals 2 times 22 over 7 times the radius.
Solving for the radius gives us 14 centimeter.
Right, now plug that 14 into the area formula, which is pi times radius squared. 22 over 7 times 14 calculates out to an area of 616 square centimeters.
And finally, question 65 covers partnership. Person A invests $18,000 for 6 months. Person B invests $12,000 for 12 months. The annual profit is 14,000 rupees. What is B's share?
In business, profit is distributed based on both how much you invest and how long you leave it there. You multiply them. A's value is 18K times 6 months. B's value is 12K times 12 months.
So A is 108,000 and B is 144,000. If we simplify that ratio by dividing both by 36,000, it basically boils down to 3 to 4.
Correct. That means out of 7 total parts of profit, B is entitled to 4 parts. 4/7 of the 14,000 rupee profit gives B a final share of 8,000 rupees.
And we made it. You made it. 35 questions, from interpreting bar graphs to untangling train speeds. I really want to genuinely congratulate you for sticking with this. You now have a solid, unfragmented framework for tackling the entire quantitative aptitude section of this model paper.
You really do. And, as we wrap up, I want to leave you with a thought inspired by question 43.
Oh, the quadratic equation where we found that no relation can be established.
Exactly, where x could have been smaller, greater, or equal to y, depending on the scenario. I actually find that deeply philosophical.
Wow, so.
Well, in a test setting, we are so conditioned to find the answer, right? To force a relationship between two variables just to feel like we've solved the problem. But sometimes variables are just too independent. Realizing when not to draw a conclusion and having the sheer confidence to look at the data and say there is no relation here is just as important a sign of intelligence as solving the most complex equation.
Wow. So the next time you're faced with muddy waters, whether it's on an exam paper or in real life, ask yourself, do these things actually connect? Or am I just forcing a solution? Keep that in mind. Until next time. When you first stare down a really rigorous reasoning test, it can feel, exactly like navigating a maze blindfolded.
Oh, absolutely. It is super overwhelming.
Right. You're dropped into this labyrinth of clues and numbers and overlapping rules, and that clock is just ticking away in the background. It's so easy to just feel completely lost.
Yeah, the pressure is real. But here is the secret we really want you to hold on to today. Every single puzzle in front of you is just a pattern waiting to be decoded.
Exactly. And you already have the key.
You do. It is so important to remember that these questions, they aren't designed to trick you just for the sake of being mean. They're designed to test your ability to bring order to chaos.
I love that way of framing it.
Yeah, if you take a deep breath, trust your logic, and just take it one step at a time, the path through that maze becomes incredibly clear. And hey, you aren't doing it alone. We are right here walking through it with you.
Think of us as your supportive mentors, just holding your hand through a really tough mental workout. Today, we are tackling a beast of a challenge.
We really are.
Our mission is to walk through the complete, unfragmented reasoning ability section. That is, questions 66 to 100 of the IBPS PO Prelims 2026 Model Paper 04.
No skipping around, no cutting corners.
Exactly. We are going sequentially from the first puzzle to the absolute last, unpacking all those strategies that will save you time and, honestly, preserve your sanity. So, okay, let's unpack this. We're starting with our first challenge, which is a linear seating arrangement.
Oh, this is a classic stress test for your working memory. So we have 7 people, A through G, sitting in a straight row. But to add a layer of complexity, some of them are facing north, and others are facing south.
Right, which always messes with my head a bit.
It does. Now, when you get a puzzle like this, do not try to hold it all in your head. You draw 7 dashes on your page, and you look for an anchor. Our clues tell us that D sits at an extreme end and faces south. A sits second from the left end and faces north.
Wait, let me stop you right there, because setting up that anchor is where a lot of people just freeze. We know D is at an extreme end, but how do we know which end?
That is a great question. You have to look at the cascading clues. If we put D on the far right end, the subsequent clues about who sits to the right or left of D start to push people off the bench entirely.
Oh, I see. They literally run out of seats.
Exactly. By process of elimination, D just has to be sitting in that very first seat on the far left. So you lock D into slot 1, facing south. You lock A into slot 2, facing north.
Okay, that makes sense.
Then the clues say F is immediately to A's right, facing south. Because A faces north, A's right is just our normal right on the page. So F goes into slot 3.
So you're just methodically following these spatial restrictions until the entire arrangement locks into place.
You got it. And from left to right, we end up with D facing south, A facing north, F facing south, B facing north, G facing north, C facing south, and E facing north.
All right, so with that map clearly drawn out, the questions in this block, questions 66 through 70, they just become a simple exercise in reading your own data, right?
Pretty much, yeah.
Like question 66 asks how many persons face south. We just scan our map. It's D, F, and C. The answer is 3. But let's talk about question 67 because it asks who sits third to the left of D.
Ah, yes. The classic trap.
Yeah, wait, I have to push back here. If D is sitting in slot 1 on the far left extreme of the row, how can someone possibly sit to their left? There are no chairs over there.
I love that you brought this up. That spatial flip is brilliant, and it's exactly the kind of trap the examiner said to see if you are paying attention to orientation.
Because D is facing south.
Yes, D is sitting on the left end of our paper, yes. But D is facing south. Imagine yourself sitting in D's chair looking south. Your physical left arm is actually pointing toward the rest of the row, toward the right side of the page.
Oh, wow, yeah. You really have to project yourself into the seat.
Exactly. So counting 3 places to D's left, we move past A, past F, and land on D.
That is such a good trick. Once you get that, the rest really do fall in line. Like question 68 wants to know who is exactly between A and B. Looking at our sequence D, A, F, B, the person in the middle is clearly F.
Right. It just pops out at you.
And question 69 asks for the immediate neighbors of G. JV is in the 5th slot, flanked by B and C. Simple enough. But question 70 introduces this pattern recognition task. It asks for the odd pair out among 5 options.
Let me guess. AG, BE, GF, FC, and DC.
Yep, those are the ones.
So when they ask for an odd pair out in a seating arrangement, they are almost always testing directionality. If you look at the pairs AG, BE, FC, and DC, both people in those pairs face the exact same direction.
Right, they're either both north or both south.
Exactly. But look at G and FG faces north while F faces south. The pattern completely breaks. They are the odd ones out.
It is incredibly satisfying when you can see the matrix like that. And, physical seating forces people into strict logical orders, but time and age do the exact same thing, which transitions us beautifully into our next block.
Ah, the year-based age puzzle. Questions 71 to 75.
Yes. Here's where it gets really interesting. I always like to compare this kind of puzzle to organizing files on a computer by date created.
Oh, that's a great analogy.
Right. Once you manage to lock in the oldest file, the rest of the files just click into the timeline effortlessly. So we have 7 people, P through V, born in specific years between 1975 and 2008. And our base year for calculating their ages is 2026.
Now, the biggest mistake you can make here is trying to calculate ages on the fly while answering the questions.
Yeah, that sounds like a nightmare.
Don't do it. Take 10 seconds right at the start to calculate everyone's age based on 2026 and write it down. 1975 means 51 years old. 1982 means 44, and so on. Now you have a clean data set.
So you do the math once and never think about it again.
Exactly. Next, we find that oldest file to anchor our timeline. The clues say exactly one person was born between S and P, and S is older than P. We also know U is the absolute youngest.
Okay, so S has to be pretty far back.
Yeah, and by threading together the comparative clues like R is born immediately after P, V is older than R, T is older than Q, you realize there is only one chronological sequence that doesn't violate its own rules.
And what does that sequence end up being?
From oldest to youngest, it has to be S, 1975, V in 1982, P in 1989, R in 1994, T in 1999, Q in 2003, and U in 2008.
And once you've built that master timeline, the questions are practically gift-wrapped.
They really are.
Whether the exam asks you in question 71 to identify who was born in 2003, which is Q, or asks in question 72 for V's present age, which we already calculated as 44, it's just reading the data off your sheet.
Precisely. Like question 73 asks how many persons are younger than R? Well, R was born in 1994. Looking down our timeline, T, Q, and U come after. That's 3 people.
Nice and easy.
Question 74 asks who is the oldest. We established that in our very first step, it's S. And question 75 wants the age difference between S and US is 51, U is 18. The difference is 33 years.
Boom. Done. If your brain is feeling a little stretched right now, please know that just means it's growing. You are doing incredibly well. We're pivoting now from chronological timelines back to spatial arrangements for questions 76 to 80.
Oh, the triangular table.
Yes, 6 people. But this time, the 3 people at the corners face away from the center, and the 3 in the middle of the sides face inward.
This is where that mental rotation skill we practiced earlier becomes absolutely vital. We start by placing A at a corner, facing out. The clues state D is immediately to A's right.
Okay, so since A is facing away from the table, A's right hand actually points in the clockwise direction along the edge, right?
You've got it. So D sits clockwise to A in a middle seat facing inward. Carefully tracing the remaining clues in that clockwise direction gives us our unbroken circle.
Which looks like what?
It goes A at a corner, D in the middle, B at a corner, F in the middle, C at a corner, and E in the middle.
Okay, let's see how they test us on this map. Question 76 asks who sits second to the right of E.
Put yourself in E's seat. E is in a middle position facing the center of the table. If you are looking inward, your right arm points anti-clockwise.
So moving second to the right from E means jumping over C and landing on F.
Exactly. The rest of the spatial checks are straightforward once you trust your map. Question 77 asks who sits exactly between A and B. Following our clockwise line of A, D, B, it's obviously D.
Right. And question 78 asks how many sit between D and C when counted clockwise from D.
So starting at D and moving clockwise, we pass B, then F, before hitting C, so 2 people.
Question 79 asks which group faces the center. We know the middle seats face inward and those belong to D, F, and E. Finally, question 80 asks for the odd pair out among AD, DB, BF, EB, and FC.
Look at the causality of those pairings.
Yeah.
In almost all of them, the second person sits immediately clockwise to the first.
Oh, I see. D is clockwise to A, B is clockwise to D.
Right, but look at EB. The person immediately clockwise to E is A, not B. The mechanical progression is broken, making EB the odd one out.
Your spatial reasoning is getting a phenomenal workout today. Take a breath, listener, because we are leaving physical tables behind and stepping into the pure logic of words. Questions 81 to 84 cover syllogisms.
Syllogisms. This is all about deductive restraint. Knowing what you can actually prove versus what you merely suspect.
Yeah, that's tricky. Let's look at question 81. It states, some phones are radios. All radios are speakers. The conclusions they want us to evaluate are Roman numeral 1, all phones are speakers, and 2, no phone is a speaker.
Now, if some phones are radios and all radios are speakers, then those specific phones that overlap into the radio category must be speakers.
Right, they're forced into that group.
But what about the millions of other phones out there? We have no data on them. So we cannot definitively say all phones are speakers.
But we also can't say no phone is a speaker because we just proved some definitely are.
Exactly. Therefore, neither 1 nor 2 follows. That is the core trap of syllogisms, assuming that a partial overlap means complete inclusion.
Let's look at question 82. All tigers are lions. No lion is a bear. Conclusions are 1, no tiger is a bear, and 2, some lions are tigers.
How do you usually visualize this one?
I always compare this to Russian nesting dolls. Think about the physical reality of that setup. The tiger doll is completely sealed inside the lion doll, and the absolute rule of this universe is that the lion doll can never, ever touch the bear doll.
Oh, I love that imagery.
Well, if the tiger is trapped inside the lion and the lion never touches the bear, then the tiger is physically incapable of touching the bear. So conclusion 1, no tiger is a bear, absolutely follows.
And for conclusion 2, if all tigers are lions, then inherently, the lion category contains tigers. So some lions are indeed tigers. Both 1 and 2 follow.
That visual analogy prevents so much abstract confusion for me. Let's apply it to question 83. Some rivers are lakes, all lakes are ponds. Conclusion 1 is some rivers are ponds, and conclusion 2 is all ponds are lakes.
Following our earlier logic, the rivers that overlap with lakes get dragged into the pond category. So conclusion 1 is rock solid.
But conclusion 2 tries to run the logic in reverse, doesn't it?
It does. Just because all lakes are contained within the pond category doesn't mean lakes take up the entire pond category. Ponds are the larger bucket. So only conclusion 1 follows.
Now, question 84 presents an incredibly important concept. All books are novels. Some novels are poems. Conclusions are 1, some books are poems, and 2, no book is a poem.
The poems might overlap with the books, or they might only overlap with the novels that aren't books.
The data is completely ambiguous.
Right. We just don't have enough info to prove either conclusion on its own. But look at the relationship between the two conclusions. If we connect this to the bigger picture, this is what we call a complementary pair.
Meaning they complement each other.
Meaning, while we can't prove either statement individually, logically, it is impossible for both to be false at the same time in reality. Either there is some overlap between books and poems, or there is zero overlap. It has to be one or the other.
Oh, wow. So the official answer is either 1 or 2 follows?
Exactly. Syllogisms train us to stop jumping to unwarranted conclusions based on incomplete information.
That is such a vital, real-world skill, honestly. Let's keep this logical momentum flowing into mathematical inequalities, questions 85 to 87.
These can look intimidating, but they follow strict rules.
I always picture inequalities like water flowing downstream in a river. If all the greater than or less than signs point the same way, the water flows smoothly and the logic connects.
That's a perfect way to look at it. Let's take question 85. We have A is greater than B, which is greater than or equal to C, and D is less than or equal to C. We need to evaluate if A is less than or equal to D, or if A is greater than D.
So let's align that chain so we can see the river. It becomes A is greater than B, greater than or equal to C, greater than or equal to D.
The entire relationship flows in one unified direction, from largest to smallest. Because A is strictly greater than B, A must be strictly greater than D at the bottom of the chain. So only conclusion 2 follows.
The water flows perfectly. But question 86 is a great example of what happens when that flow is interrupted. We have K is less than or equal to L, which is less than M, but then N is greater than M.
Let's build the chain. K is less than or equal to L, less than M, less than N. The conclusions ask if K equals N or if N is less than L.
When we look at our unified chain, it clearly states N is the largest value, right?
Exactly. N is strictly greater than K, so they cannot be equal. And N is strictly greater than L, so N cannot be less than L. Neither conclusion follows. But let's take that a step further. What if the signs point at each other? What if it was L is less than M, which is greater than N?
That is a dam in the river. The less than sign hits the greater than sign, the logic stops flowing, and absolutely no relationship can be proven between the variables on opposite sides of that dam.
Precisely. Let's finish inequalities with question 87. R is greater than or equal to S, which equals T, and T is greater than U. Conclusions are 1, R is greater than U, and 2, S is greater than U.
Because S and T are mathematically identical and T is strictly greater than U, both R and S must be strictly greater than U.
The logic bridges the gap effortlessly. Both 1 and 2 follow.
You are doing exceptionally well navigating these different rule sets. We are shifting now into blood relations, questions 88 to 90.
Decoding family trees requires tracking generational steps without getting lost in the grammar. Take question 88. Pointing to a photograph, Mina says, "He is the brother of my daughter's mother." How is the man related to Mina?
This one is a fun little grammar riddle. Whenever you see a phrase like this, you just work backwards and simplify. Who is my daughter's mother?
Well, assuming Mina is speaking about her own daughter, Mina is her daughter's mother.
Exactly. You can just cross out that whole phrase and replace it with me. So the sentence becomes, he is the brother of me. He is her own brother.
Breaking down the phrasing is key. Now, question 89 introduces coded relations.
Oh, I like these.
The rules are A#B means A is the wife of B. A*B means A is the son of B. What does the specific chain M#N*O mean for M and O?
The trick here is don't try to hold the symbols in your head. Translate them into a sentence immediately. M#N means M is the wife of N. N*O means N is the son of O.
So put it together. M is married to O's son.
In family tree terms, that makes M the daughter-in-law of O.
Spot on. Question 90 requires sketching a quick tree. X and Y are brothers. Z is the father of Y. W is the sister of V, and V is the son of X. How is W related to Z?
Let's track the generations downward. If V is X's son and W is V's sister, then W and V are both children of X, so W is X's daughter.
Good. Now track upward.
Since X and Y are brothers and Z is the father of Y, Z must also be the father of X, so W is the daughter of Z's son. That makes W the granddaughter of Z.
Finding your way through a family tree really is just like finding your way across a map. Which brings us perfectly to direction sense, questions 91 to 93.
Oh, spatial tracking.
Question 91. Rohit walks 6 kilometers south, turns left, and walks 8 kilometers. Where is he from the start?
Well, if he is facing south, a left turn actually points him east, so he is 6 kilometers south and 8 kilometers east of his origin point. Drawing a straight line from start to finish puts him in the southeast direction.
Simple enough. But question 92 is where test takers lose precious time. A man facing north walks 4 kilometers, turns right and walks 4 kilometers, turns right again and walks 4 kilometers, then turns left and walks 3 kilometers.
That's a lot of turns.
It is. How far is he from his starting point? Now, you could draw a massive winding map for this, but under a time limit, how do we solve this in 5 seconds?
You cancel out opposing vectors. Think about his vertical movements. He walks 4 kilometers north. Later, after 2 right turns, he ends up walking 4 kilometers south.
Going 4 north and 4 south puts you at a net 0 vertical movement.
Yeah, those lines completely cancel each other out. All we are left with are his horizontal movements. He walked 4 kilometers east and then another 3 kilometers east. Add them up, and he is exactly 7 kilometers east of his starting point. No map required.
That vector cancellation trick is an absolute lifesaver. Let's look at question 93, which tests environmental logic. One evening before sunset, Ram and Shyam stand facing each other. Shyam's shadow falls exactly to his right. Which direction is Shyam facing?
Okay, you have to know how the sun works for this one. In the evening, the sun is setting in the west. That means every single shadow on Earth is being cast toward the east.
Right.
So if Shyam's shadow is falling to his right, it means his physical right arm is pointing east. If you stand up right now and point your right arm to the east, your face has to be pointing north. Beautiful deduction.
It really is. All right, take a deep focusing breath. You are in the home stretch. We're closing out this model paper with a rapid-fire mental agility drill. Number operations, ranking, and coding, covering questions 94 to 100. Let's power through.
I am ready.
We're given 5 numbers, 584, 271, 738, 462, and 359. Question 94 asks, if the digits within each number are arranged in ascending order, which original number becomes the largest?
The trick here is you don't need to write out every new number. You just need to look at what the smallest digit in each group is, because that will become the new first digit.
So 584 becomes 458,
271 becomes 127, 738 becomes 378.
462 becomes 246, and 359 just stays 359.
The largest new number is 458, which originated from 584.
Perfect. Question 95 asks for the sum of the first and third digits of the second largest original number. Looking at the raw list, 738 is the largest, and 584 is the second largest.
The first digit is 5, the third is 4. 5 plus 4 is 9.
Simple tracking. Question 96. If 1 is added to the middle digit of each original number, how many of those new middle digits will be even?
The original middle digits are 8, 7, 3, 6, and 5. Adding 1 turns them into 9, 8, 4, 7, and 6. Looking at that new list, 3 of them, 8, 4, and 6 are even.
Let's move to ranking, which is really all about overlapping counts. Question 97. Ravi is sitting 9th from both ends of a row. How many students are there?
If he is 9th from the left, there are 8 kids to his left. If he is 9th from the right, there are 8 kids to his right. Add the 8 on the left, the 8 on the right, and Ravi himself in the middle. 8 plus 8 plus 1 gives us 17 students total.
Question 98 takes that overlap concept and applies it to a position swap. Asha is 14th from the front of a queue. Binu is 20th from the end. They swap places. The clue tells us that Asha's new chair, which used to be Binu's, is now 17th from the front. How many people in the queue?
We just need to analyze that specific chair. We are told it is currently 17th from the front, but from the initial setup, we already knew this exact chair was 20th from the end.
So we have the location of the chair from both directions.
Yes. To find the total, you add the position from the front, which is 17, to the position from the end, which is 20, and then you just subtract 1. Why do we subtract 1? Because we counted that specific chair twice. 17 plus 20 minus 1 equals 36 persons in the queue.
Almost to the finish line. Question 99 is coding decoding. The word bright is written as CQJFIS. Based on that rule, how is planet written?
Look at how bright shifts. B moves forward to C, so that's +1. R drops backward to Q, -1. I moves forward to J, +1.
It's an alternating forward-backward alphabetical shift.
Exactly. If we apply that exact same +1, -1 alternating pattern to planet, P goes forward to Q, L goes backward to K, A goes to B, N to M, E to F, and T to S. The answer is QKBMFS.
And finally, question 100. In the word journalist, every vowel is replaced by the previous letter in the alphabet, and every consonant by the next letter. Which letter appears exactly twice in the result?
Let's see. If we run that transformation, the vowel U drops back to T, and the consonant S moves forward to T. T is the only letter produced twice by these rules.
And with that, you did it.
Wow, you really successfully navigated the entire reasoning ability section.
Think about the sheer variety of cognitive gymnastics you just performed. Over 35 dense questions. You built historical timelines, mapped physical orientations, evaluated strict categorical logic, and rapidly decoded abstract numerical rules.
It's a lot.
We are incredibly proud of you for sticking with us.
Absolutely. The key is to never view these questions merely as obstacles standing between you and passing grade. View them as specialized tools. Every puzzle you dissect, every trap you identify, like that spatial flip with D facing south, it hones your analytical mind.
Consistent practice is what builds this mental muscle memory. You are sharpening a skill set that goes far beyond a single examination.
When you train your brain to quickly identify who sits where, or to intuitively grasp which direction a mathematical inequality is flowing without getting bogged down in the variables, you aren't just prepping for a test. You are rewiring your brain to rapidly process raw information.
That is the perfect way to look at it. You are literally training yourself to turn real-world chaos into actionable order.
So I want to leave you with this final thought as you step away from this session and go about your routine today. What patterns in your daily life, in your conversations, or in your schedule are just waiting for you to decode them? Keep that curiosity alive. Keep decoding.